Hello everybody and welcome to Notes 7.6. So today we're going to be learning about natural logarithms. The great thing about natural logarithms, it has all the same properties, all the same stuff as a logarithm. The only difference is that this function is in base E. So if you guys notice here, we're going to be in base E. So what we use for natural logarithm is we use this ln. So ln is the same as the natural logarithm. It's the same as log with base e. So natural logarithm is base e. All right, and then its inverse is going to be y equals e to the x power. Just a reminder again, e is just this irrational number that continues forever and ever and ever that we've given a name to, similar to pi. So e is approximately 2.7 dot 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 dot. So we just use about 2.7. All right, so we have these different properties. These are the same properties as the other logs we've already talked about. So it's all the same. So when we have multiplication, when we expand it, we have addition. When we have natural log division, when we expand it, we have subtraction. When we have a power, we bring the power down in front. And then we have our change of base formula. For natural log, we're not going to really have to use change of base just because calculators and stuff have natural log buttons, so it's not really necessary. All right, so we're going to go ahead and talk about our first one. So we have the natural logarithmic function is its inverse is y equals e to the x. So we're going to graph y equals e to the x, and then we're going to graph its inverse. So we're going to start with y equals e to the x. All right, so again, e is approximately 2.7. There's a button on your calculator that has an e. That's how we'll use it. So we're going to go ahead and make a t-chart. These are my x values. These are my y values. These are going to be for e to the x power. So let's start with 0. So e to the 0 power, or anything to the 0 power, is going to give me 1. If we plug in 1, we would get e to the first power, which is approximately 2.7. If we plugged in 2, let's go ahead and do that on our calculator. So if we did e times e, so if you guys notice, there's an e button right here. So e times e will equal 7.4 approximately. So we have 7.4. All right, so that's good enough, 3 points. Let's go ahead and graph those. So we have 0, 1, 1, 2.7 about, and 2, 7.4, which would be, it'd even be higher than that, just approximating, like way up here. And then we're going to connect. Remember, exponential models are not going to pass 0 or touch it. So there's that horizontal asymptote on that x-axis. So this is our graph, y equals e to the x power. All right, now we're going to do its inverse function. So remember, to find an inverse, we're going to swap x and y. So we have y equals e to the x. We're going to switch these, so we're going to get x equals e to the y function. Okay, we want to solve for y. So remember, to get something out of an exponential, we change it to a logarithm. Those are inverse operations of each other. So it goes log base answer equals exponent. So we have log base is e, answer is x, equals my exponent is y. Okay, we just learned log base e is really natural log. So we're going to use ln of x equals y. So the natural log of x equals y. All right, so when we go ahead and graph this or make a t-chart, the easiest way to make a t-chart is taking your inverse function and swapping all your x's and y's. So that's precisely what we're going to do. We're just going to swap all of these points. So now we're going to have 1, 0, 2.71, and 7.42. Okay, so we have 1, 0, 2.71, approximately there, and 7.42 approximately. Okay, so now this is going to approach a vertical asymptote. So this is my inverse function of, so that's going to now approach a vertical asymptote at x equals 0. Okay, which makes sense. So this had a horizontal asymptote at y equals 0. This has a vertical asymptote at x equals 0. And it makes sense because for inverse functions, we swap x and y. So it makes sense that one has y equals 0, and then we swapped it with x equals 0. All right, let's go ahead and go to our next page. So now we're just going to simplify these expressions. All of these we can do by hand. We do not need a calculator. So just a reminder, we're going to set this equal to p, and we want to figure out what p is. Because remember, it goes log base answer equals exponent, so we're using p for power, which is the same as exponent. So what we can do is we can rewrite this into its exponential form. So my base is e, my power is p, and my answer is 1. So I'm asking myself, e to what power equals 1? E to what power equals 1? Well, e to the 0 power equals 1. So I'm looking for p, so that means p has to be 0. So this is equal to 0. All right, same with this next one. This is equal to p. We're trying to figure out what p is. So log base answer equals exponent, so my base is e, my exponent is p, my answer is e to the 8th. Okay, notice whenever my bases are the same, okay, then we set our exponents equal to each other. So we're just going to get, then p has to be 8. So this guy equals 8. All right, C, natural log of e. So again, we're trying to figure out what this equals. It equals some power, change it. My base of natural log is e. My exponent is p. My answer is e. Well, again, my bases are the same, so we set our exponents equal to each other. E is technically to the first power, so I would say p is equal to 1. All right, and last one. So last one, we're going to evaluate the top, which is ln of e cubed equals p. We want to evaluate this, get that answer, and then we're going to divide that answer by 6. So again, my base is e, my power is p, my answer is e to the 3rd power. Again, my bases are the same, e equals e, so my exponents are equal. So p equals 3. So this top guy equals 3. And then we're going to take 3 and divide it by 6. Simplify 3 over 6. 3 over 6 is 1/2. So this would equal 1/2. All right, perfect. Let's go to our next one. So it says, write each expression as a single logarithm. So we just want to go ahead and condense these into a single logarithm. Okay, so for any of these, the first thing you guys are checking for is there a number in front? If there is numbers in front, remember those are exponents, and we're going to go ahead and move those first. So if you guys notice on this first one, I have this 2 out in front. So my first step is moving it back to the exponential position. So we're going to have ln of 7 plus ln of 5 squared. All right, we know what 5 squared is, so we're going to do what 5 squared is. So we have ln of 7 plus ln of 25. Okay, now we want to condense it. We have a plus. Plus condensed is going to be multiplication when we write it as a single. So we have natural log of 7 times 25. And 7 times 5, or 7 times 25, we know how to do that. So we have natural log of 175. This is my simplified condensed form. All right, let's go ahead and try the next one. So again, step 1, move our exponents back. So we're going to end up getting ln of x cubed minus ln, be careful, this whole 2x is being squared. Everything inside that natural log is being squared. So we're going to have natural log of x cubed minus natural log, 2 squared is 4, x squared is x squared. All right, so that's all simplified. We have subtraction. Subtraction is really division, so we're going to go ahead and divide these. So natural log of x cubed divided by 4x squared. And then if you can simplify this, this can be simplified. I have 3 x's in the numerator, 2 x's in the denominator, so 2 of them are going to cancel out. So that's going to leave me with natural log. There's going to be 1 x left in the numerator and a 4 left in the denominator. All right, let's go ahead, try C. So again, step 1, move our exponents back. So we're going to move this back, and we're going to move that back. So we're going to have natural log. So this 1/3 is going to be applied to everything inside that parentheses. So we're going to have x to the 1/3 power plus natural log of 8 to the 1/3 power minus my natural log of y to the 4th power. All right, simplify anything that we can. The only thing I can simplify is I know what, so remember this means cube root. I know the cube root of 8, so I'm going to do the cube root of 8. So we have natural log of x to the 1/3 plus natural log 8 to the 1/3, so the cube root of 8 is 2, minus natural log of y to the 4th. Okay, so again, plus is going to be multiplication. It's going to be in your numerator. Minus is going to be in that denominator. So let's write it as 1. Natural log of x to the 1/3 times 2 divided by y to the 4th. And I'm totally fine with this answer. The other way we can write that is take that 1/3, and that's really a cube root, so we could write it like that as well. So we have natural log of 2 times the cube root of x over y to the 4th power. Okay, if you haven't done so, let's go ahead and pause the video here. I want you guys to just attempt D all by yourself to see if you are on the right track. All right, so again, step 1 is moving my exponents back. So now we're going to have natural log of e cubed plus natural log of x squared plus natural log of y. Okay, and then we want to go ahead and put this all into 1. It's all pluses, so we're going to have all multiplication. So natural log of e cubed x squared y. Hopefully you guys all got that one correct. Okay, so now we're going to go ahead and start solving. So whenever we solve, no matter what it is, you're going to identify what we're trying to isolate. So I'm trying to solve for or isolate x. X is inside this natural log function. A mistake I see some students do every single year is that they think these are like separate. No, this is inside that function. They are one in itself. You can't just go, oh, I'm just going to divide each side by natural log. No, it doesn't work like that. So that x is stuck inside that natural log. So step 1 is isolate the natural log of x. It's already isolated. So now whenever we want to get something out of a log, we do its inverse function. Remember, the inverse function is going to be the exponential. So for an exponent, we have a base to an exponent equals an answer. And when it's in its log form, we have log base answer equals exponent. So we're going to take it from this log form and put it back into its exponential form. So our base of natural log is e. My exponent would be 2, and my answer would be x. You just solved for x. This is the answer I like. This is called an exact answer. So if I said, give me the exact answer, this is what you tell me, x equals e squared. If I asked for an approximation, because sometimes it is, if I ask for that approximation, that's where we plug it into a calculator. So that's when we get x is approximately, and again, it would be this number, because this is e times e, so 7.389. So x is approximately 7.389. Again, in this class, we practice rounding 3 decimal places, unless it's money or it tells you to round to the nearest whole. Okay, so for this guy, we want to go ahead, isolate where the x is. The first thing you're going to want to do with this is, because it's being squared, is we're going to bring down the square in front using that power property. That's going to allow me to get rid of that squared by dividing each side by that number. So we're going to have 2 natural log of 3x plus 5 equals 4. So we're trying to isolate that natural log of 3x plus 5. So now that that 2 is in front, I can easily divide each side by 2. So now I have natural log of 3x plus 5 equals 2. Again, I want to get something out of a log function. The opposite, or how to get something out of a log function, is changing it back to its exponential form. So the base of natural log is e, the exponent would be 2, and my answer is 3x plus 5. Okay, and then you guys just solve this like normal. We'll subtract 5 from both sides. So we have e squared minus 5 equals 3x. We'll go ahead and divide each side by 3. So my exact answer would be x equals e squared minus 5 divided by 3. This is my exact answer. Again, if you were asked for an approximation, that's where we plugged this into a calculator. So we would have e squared, which is right here, minus 5. And then we take that number and divide it by 3. And we get 0.796. So this is approximately 0.796. All right. Okay, let's go ahead, pause the video here. I want you guys to attempt this one all by yourself. I'll give you a hint. So this is currently in 2 different natural logs. What I want you to do is condense it into one natural log, isolate, and solve. All right, so for this guy, we need just one natural log. So we're going to condense. So we have natural log of 2x times 3 will equal 2. So we have natural log of 6x equals 2. Isolate the natural log that has our x. It's isolated. To get it out of a natural log, or to get anything out of a log, change it back to its exponential form. My base is e. My exponent is 2. My answer is 6x. And then you just solve for x. So we divide by 6, divide by 6. So we would get x is equal to e squared divided by 6. And that is all. Okay, again, if we had an approximation, you're just using a calculator. So e squared divided by 6 would have been 1.232. Okay, so now we're solving exponentials. So now we're just going the opposite direction. We're going to isolate my exponential, then I'm going to change it to a logarithm to get it out of an exponent. So again, step 1, identify where your x is and then isolate it. So I have e to the negative x, so I'm trying to isolate this first. So I'm going to go ahead, subtract 3 from both sides. So we have 2e to the negative x equals, it's going to give me 22. Then we can divide each side by 2. So we have e to the negative x equals 11. Okay, so now from here, to get something out of an exponent, so that x is in an exponent, this is where we do the inverse function using a logarithm. So we go log base answer equals exponent. Well, this is base e, so we're using a natural log. So we get log base, so that's log base e, answer is 11, equals my exponent, which is negative x. Okay, almost there. We want this to be x, so we're going to just divide each side by negative 1. So we end up getting x is equal to negative natural log 11. And that is all. Okay, again, if we were asked for an approximation, we just plug this into a calculator. So here's just a basic calculator. Phone calculators are like a little backwards, I would say. So you do the number first, you hit 11, and then you hit the ln button. So if you notice next to the log button, there's an ln button, click that. So we have the natural log of 11 is 2.397, 2.398 rounding, and then we put a negative in front because it's negative natural log of 11. So we would get x is approximately negative 2.398. Perfect. Okay, looking at, oops, went too far. Okay, looking at B. So again, step 1, isolate. This guy's already isolated. So since I'm already isolated, get it out of an exponent, we change it to a logarithm. This is a natural logarithm because it's base e. So we have natural log of my answer equals my exponent. Okay, solve for x, we just add 2 to both sides. So we get natural log of 12 plus 2, this is on the outside of the function, 12 plus 2 equals x. And that's your answer. Sometimes I have students who say, oh, well, 12 plus 2 is 14, so this is natural log of 14. No, these are completely separate. This 12 is inside of a natural log, this is not. So we would do the natural log of 12 and then add 2 to that answer. So again, if we were practicing on our calculator, you would put in 12, take the natural log, and then add 2, which equals 4.485. So x would approximately be 4.485. All right, let's go ahead, pause the video, and try this one all by yourselves. All right, so step 1, isolate. So now we have e to the 3x power equals 10. Okay, now that I'm isolated, to get it out of an exponent, we change it to a logarithm. So we get ln of 10 equals 3x. And then to get x by itself, we're just going to divide each side by 3. So we'll end up with x is equal to the natural log of 10 divided by 3. And that is all. Again, this is called the exact. And if we did an approximation, you should have gotten 0.768. All right, last problem, a word problem, but it's not too difficult at all. So it tells us in this formula, h equals 1 divided by r, natural log of p minus natural log of a models the number of hours it takes bacterial culture to decay, where h is the number of hours. So let's just write down all of our variables we have. So we have h, which is my hours. We have r, which is my rate. We have p, which is my initial amount. And then we have a, which is the reduced bacteria, not like the after amount. So it says, a scientist determined some antibiotic decays a population of 18,000. So my starting point is 18,000, or my P. Bacteria to 4,200, so that would be my after population, in 24 hours, so that would be my H. Find the rate of decay, so we're looking for R. So we're just going to go ahead and plug into that formula. So we're going to have 24 equals 1 over R times the natural log of 18,000 minus the natural log of 4,200. Okay, we're solving for r. First thing I want to do is get r out of the denominator, so we're going to multiply both sides by r. So now I have 24r is equal to, and then we can easily condense natural log of 18,000 divided by, or minus natural log of 4,200 by using division. So we'd have natural log of 18,000 over 4,200. We'll just get rid of those zeros just to make our life a little easier. Okay, to get rid of that r, or not to get rid of the r, to get rid of the 24 in front of the r, we're going to divide each side by 24. So we are going to plug in r equals natural log of 180 over 42. Yes, I am aware we can simplify this more, but we're going to use a calculator, so there's no point. Divided by 24. So go to our calculator. Again, you want to do the inside first, so we're going to do 180 divided by 42. We want to take the natural log of that, so we take ln, and then we take that answer and we're dividing it by 24 to get 0.0606. So my rate is approximately 0.0606. And remember, we want to go ahead, change this back to its percentage form. So we get our rate of decay. And for percentages, we move it 2 decimal places. So the rate of decay is 6.06%. All right, for this guy, a laboratory assistant tests the antibiotic that causes the rate of decline of 0.16. How long should it take for a population of 5,000 to shrink to 400? So now we're looking for our hours. So still plugging into that formula. H equals 1 divided by r. My r is 0.16. Natural log of my original 5,000 minus my natural log of 400. So we're going to get H equals 1 over 0.16. Let's condense these to be our natural log of 5,000 over 400. Okay, and then we use a calculator. So H is approximately, using just a basic calculator here, we're going to do that 50 divided by 4. We're going to take the natural log of that, and then we're going to multiply by 1 divided by 0.16, which is the same thing as just dividing by 0.16, which equals 15.786. So we have 15.786. So we want this in hours. Let's see if you guys can figure out, what is 0.786? How many minutes is 0.786? See if you can figure that out. So it will take 15 hours and 47 minutes for the population to shrink to 400 bacteria. All right, and that is going to go ahead and conclude our notes for 7.6. I hope you guys all have a fantastic day today.